Welcome all of you. Welcome to ANIMATHS. Now, as said before, this video we are going to take up midpoint theorem and also converse of midpoint theorem. Now, I am not taking up the derivations of midpoint theorem and converse of midpoint theorem because they have been deleted from your portions. So, we shall be taking the statements directly and we shall be using them to prove sums. Okay. So, let's see. First, we'll see the statements. Okay, it is important to know the statements in order to solve the sums. So see to it that before you are trying to solve the questions, you have noted down the statements and you know the statements well. Okay, so let's start with it. This is midpoint theorem. It says a line joining the midpoints. The line joining the midpoints of two sides of a triangle is parallel to the third side and half of it. Okay, so this is the statement of midpoint theorem. Now let's see what the diagram says. Here we have a triangle. Now in this triangle, let it be A, B and C, and in this, here we have a line joining M and N. Okay, a line joining M and N. So M is the midpoint of AB and N is the midpoint of AC. Now it does not say that AB and MN is of same length. Okay, so M is the midpoint of AB and N is the midpoint of AC, and therefore this line is parallel to this and MN is also equal to half of BC. Now in these sums, it is important in the two theorems to understand what is given and what is to be proved. So if you see a line joining the midpoints of two sides of a triangle, you have to recognize the given part. The given part is the midpoint of the two sides of the triangle is mentioned. That is, it is a fact. Now if it is so, then this part should happen. So the given part is M and N are the midpoints, and to prove that part is Mn is parallel to this and Mn is half of it. Okay, so this is the midpoint theorem. After this, we are going to take up the converse of midpoint. Okay. So what does converse of midpoint theorem say? A line starting from the midpoint of one side of a triangle parallel to the second side bisects the third side. Okay, bisects the third side. So here, what does it mean? What is the given part? As I said, it is important to understand what is given and what is to prove. The given part in triangle ABC now is M is the midpoint. It is, the line is starting from this. It is going parallel to the second side. Now any one side can be the second side. Even this can be the second side as required. So Mn is parallel to BC. Then, so if M is the midpoint and this line is going parallel to this, therefore it is also bisecting the third side, means N is the midpoint of the side AC. Okay, so this is what it is meaning. Now though the statement does not mention, but Mn is still half of BC even here. The statement does not mention it, but it is still, Mn is still half of Bc. That means if this is a 6, this will be a 12. Okay, so this is the statement of converse of midpoint theorem. We can clearly see the given and the to prove thing has got changed here. Earlier one, given was these two are midpoints and this is half of this and parallel to this. This one, this is starting from the midpoint, going parallel to this, then it should be bisecting this. So depending on the sum, we shall be stating with the help of which theorem, the converse of midpoint or the direct midpoint, have we proved the sum. So it is very important to understand the two theorems very, very clearly. So here we have ABC as an equilateral triangle. FED are the midpoints. FED are the midpoints of the sides AB. Then of the sides AC we have E. Okay, and of the side BC we have D. Okay. Then you have to prove that FE, that triangle DEF is also an equilateral triangle. We have to prove the smaller one is also an equilateral triangle. So how do we prove it? Here DE is, we can write DE is parallel to this because they have told these are all midpoints. So we can do this. Okay, and another thing, they are all equal sides because ABC itself is an equilateral triangle. So we can write it like this. Therefore, FE is parallel to BC. This is the sign for parallel. FE is also half of BC. Now all this is coming from midpoint theorem. Okay. Now the next one is DE is parallel to AB, yes, and DE is also equal to half of AB. This is also coming from midpoint theorem. So you write a ditto sign here. Okay, then comes the third one, FD. FD is parallel to AC and FD is equal to half of AC. This is also coming from MPT, midpoint theorem. Okay, so we have all these things. Now we can write FE is equal to DE is equal to FD. FE, therefore we can write FE is equal to DE is equal to FD. Now why so? Because they are all half of equal sides. Half of equal, we can write FE is equal to DE is equal to FD because they are all half of equal sides. Okay, they are all half of equal sides. Therefore, since FE is equal to DE is equal to FD, that is these three are now equal. Therefore, triangle DEF is an equilateral triangle. Okay, hence it is proved. So with midpoint theorem you can see that we have proved it very easily. So here is a sum. ABCD is a parallelogram. This sign is for parallelogram. You can use it in maths. E and F are the midpoints of AB and CD. This is the midpoint, this is the midpoint of this parallelogram. Prove that. What do we have to prove? CE and AF trisect the diagonal. Means this line and this line is cutting the diagonal into three equal parts. In other words, this part is equal to this part is equal to this part. We have to prove. Okay. So how do we prove it? Proving, first thing is, the first thing will prove that AECF, okay, this AECF is a parallelogram. So first is proving AECF is a parallelogram. Now you'll see why we need to prove it. Okay. Now how can we prove this is a parallelogram? Remember, this part is equal to this part because it is already a parallelogram. Now this is the midpoint, means they are equal parts. So FC is equal to half of DC, also AE is equal to half of AB, isn't it? AE is equal to half of AB, FC is equal to half of DC. Okay, therefore AE is equal to FC. Why? Because DC is equal to AB. Okay, and AE is also parallel to FC. Therefore, AECF is a parallelogram. Okay, so AECF is a parallelogram, has been proved, because one side has been proved to be parallel and equal. Okay, so we can say yes, it is a parallelogram. Now this concept has been explained very well in my previous video, that is quadrilaterals and parallelograms. You can get the link in the description box. Now, therefore, AF is parallel to EC, opposite sides of a parallelogram. Since we have already proved this is a parallelogram, now we can say this. Okay, so these two lines become parallel. Now we are going to take advantage of that. Okay, so how do we work on it? In triangle ABQ, okay, so let us see this triangle ABQ. In triangle ABQ, PE is parallel to AQ, isn't it? PE, this is PE, yes, and it is parallel to AQ because PE is parallel to AQ. Okay, and AE is equal to this part, is equal to this part, because they already told this is the midpoint. AE is equal to EB. Okay, so now we can say, therefore we can say PQ is equal to PB, this part is equal to this part, PQ is equal to PB. Okay, this is coming from converse of midpoint theorem. Okay, so from converse of midpoint theorem we got this. Okay, now we'll get the second part. Till now we have only got this part is equal to this part. Okay, now we also need to prove this much part is equal to this much part. Then we can prove that it is a these 2 points are the points of trisection. Okay, in triangle DCP, okay, this line is already parallel to this. QF is parallel to PC, that is because it's parallel here, it will be parallel there. Here it is already the midpoint, so DF is equal to FC. DF is equal to FC, that is given. Therefore, DQ is equal to QP. DQ is equal to QP. Now, why is DQ is equal to QP? By converse of midpoint theorem. Okay. So now we have DQ equal to QP and QP was already equal to PB. Therefore, CE and AF trisect the diagonal DB. Trisect the diagonal BD. So we could prove it. So I repeat, this can be slightly difficult sometimes. First we prove this thing is a parallelogram, that is AECF. We once prove it is a parallelogram, then we can say these two lines are parallel. Once we say these two lines are parallel, we can apply converse of midpoint theorem, because line going from the midpoint of one side of a triangle going parallel to the second side bisects the third side. So PQ becomes equal to PB. Coming to the next part, this line is already parallel to this because it's a continuation here. Okay, and this is already the midpoint, therefore Q is the midpoint. So this part equal to this part is equal to this part. These two lines trisect the parallelogram. Okay, so let's see the next sum now. Now, here is the question. we have a trapezium here which is ABCD, and one thing that has been given which does not come with the definition of a trapezium, it is an isosceles trapezium. AD is equal to PC. Okay, PQR is at the midpoints of AB, DB, CD and CA. Prove that PQRS is a rhombus, that is the figure inside is a rhombus. Now before even I start with the sum, I want to tell when do we say that a particular figure is a rhombus. We can say a particular figure is a rhombus when only all four sides are equal. We don't have to prove anything else. We don't have to prove it's a parallelogram. Simply in a quadrilateral, if all four sides are equal, we can say it is a rhombus. Another thing, if it is a rhombus and beyond that, if you want to prove it is a square, then go ahead and prove that the angles are 90 degree. But if you prove only the four sides are equal, it becomes a rhombus. Okay, so here, so let us start. QR is always QR. We have to be a little careful about the triangles we are taking. QR is parallel. QR is parallel to BC, right? Now why is QR parallel to BC? Because this is the midpoint, R is the midpoint and Q is also the midpoint. Therefore we are talking about the triangle CDB. Okay, I am not writing that because sometimes if I write too much, it creates a lot of confusion. We are talking about the triangle CDB, and in that we have this side's midpoint as R and DB's midpoint as Q. So we can write this, and QR is also equal to half of BC. That is also correct. Okay, now this comes from MPT. Let's talk about the next one. PS is parallel to PC. PS, where is PS? This PS is parallel to BC. Now BC is this. So which triangle have we considered? BAC. So this line is again parallel to this. Before this it was this line parallel to this. So both the lines are parallel to the same line, and PS is also equal to half of BC. Okay, so if it is so, we can say now that QR is equal to PS, isn't it? QR is equal to PS because they are equal to half of the same line. Okay, and also QR is also parallel to PS. Why? Because they are parallel to the same line, so they themselves are also parallel to one another. So that much is for the first two triangles. Okay, so with this they are equal and they are parallel, so we can say PQ, therefore PQRS is a parallelogram. That much is proved, that PQRS is a parallelogram. Now we can try out the second thing with two more sets of triangles, that is QR is also QR is equal to half of BC, and one more thing that we can do now is PQ. PQ is here, that is equal to half of AD, but then BC and AD are equal to one another. If BC and AD are equal to one another, then we can say QR is equal to PQ, isn't it? And it is already a parallelogram, therefore this PQ is going to be equal to RS without any further proof, because they are opposite sides of a parallelogram. Okay, so since they are opposite sides of a parallelogram, we can say this part is equal to this. Now QR is equal to, therefore QR is equal to QP, and QP is also equal to RS. Okay, so we can therefore write, so QR is equal to half of BC, that we already know. Now we are going to write PQ is equal to half of AD, yes, and BC is equal to AD, isn't it? BC is equal to AD. Okay, why BC is equal to AD? Because this is given, yes. Therefore what can we say now? QR is equal to PQ. If this is equal to this, then this is equal to this, therefore QR is equal to PQ. Okay, and QR is also equal to PS, that we have already proved in the previous one. Okay, so from this we can write now RS. Okay, so we can write RS, that is the side we hadn't talked about till now, that side is equal to PQ because they are opposite sides of a parallelogram, and PQ is equal to QR, we just proved, and QR is equal to PS. Okay, therefore PQRS is a rhombus because we have just proved all sides are equal. That's it. So I repeat this. Okay, can be slightly confusing, and this sum can be confusing in a hurry. So here we have CDB. We proved RQ parallel to BC and RQ equal to half of BC. Also, we proved SP equal to half of BC and parallel to BC. So, since they are equal to the half of same thing, they are equal amongst each other, and they are also parallel because they are parallel to the same thing. So, this figure, the inside figure PQRS became a parallelogram. Okay. Once it is a parallelogram, we know that this side is also equal to this side. We know that, isn't it? This side RS is also equal to PQ. But then we start one more proof now. The second proof is PQ is equal to PQ. This line is equal to half of this. But this was equal to this. So finally this PQ is equal to half of BC. So what we come to the conclusion, RQ equal to PQ is equal to PS, and PQ already equal to SR. Therefore, all four sides are equal. Since all four sides are equal, this becomes a parallelogram, a rhombus. Okay, so first we prove it as a parallelogram and then we prove it as a rhombus. Now this is the sum. Here we have two rectangles. The big one is also a rectangle and the smaller one is also a rectangle. Okay, they have told it, and they have told Q is the midpoint of AC. AC is the diagonal. We have to prove DP is equal to PC and PR is also equal to half of AC. So how do we prove it? PQ is parallel to CR, that is this one is parallel to CR, isn't it? So these two lines are parallel because this is a 90 degree, isn't it? So this is, see, co-interior angles are supplementary, so it is parallel, and anyways they are sides of a rectangle. So this is parallel to this. Next comes, it is also, PQ is also parallel to AD. Now if this line is parallel to this and this one is parallel to this, then these two lines will be parallel. Okay. Therefore, and Q is the midpoint of AC. So, in triangle DCA, okay, so we are in triangle DCA. We can say that AQ is equal to QC because Q is the midpoint, they have told, and PQ is going parallel to DA. Therefore, P is the midpoint of DC. Therefore, we have proved DP is equal to PC. The first part we have proved. Okay. Now coming to the second part, PR is equal to half of AC. How do we prove PR is equal to half of AC? Now in triangle CAB, okay, if you see this triangle, we have already proved this is the midpoint. Now in triangle CAB, if you see, Q is the midpoint, so this part equal to this part. Okay, now we can also say this line is parallel to this. Now why is this line parallel to this? It is parallel to this because here we have a 90 degree and here also we have a 90 degree. So alternate corresponding angles are equal, so these two lines are definitely parallel. So a line coming from the midpoint of one side of a triangle going parallel to the second side will definitely bisect the third side, hence these two parts are equal. So R becomes the midpoint of CP. So now we are ready with P is the midpoint of DC, R is the midpoint of CB. Okay, if it is so, then if we join PR, we can always say, therefore we can always say that PR, since, so we can always say that PR is equal to half of dB. Okay, PR is equal to half of dB. Now PR has become half of dB. Okay, not half of AC as they have wanted, but then we can write in the next step PR is equal to half of AC. Why we can write it? Because diagonals are equal in a rectangle. Okay, so in this sum I haven't written one step, that is proving R is the midpoint. So MPT, when I proved for CAB, that step I haven't written because it is quite a repetition. So you can write it by yourself. This is the last step in the sum. So why is it equal to half of AC and why PR is equal to half of dB? I hope you understood that, because by midpoint theorem. Okay, direct midpoint. Now here is a sum which says in triangle ABC, AD is the median. Now first thing you have to understand what is a median. A median is if you have a triangle, line joining the vertex to the opposite side midpoint is called the median. From here also, opposite side is called the median. From here also to the opposite side is called the median. Okay, so a triangle, that is all these will be equal. Okay, so bisects the opposite side, then it becomes a median. So this point is called the centroid and the lines are called medians. So in a triangle there is always, no matter what kind of triangle it is, obtuse, acute, right angled, any triangle, it will always have three medians. Okay, so here we have the medians. So AD is the median, so immediately we can think like this. Okay, now they have told, and E is also the midpoint of this. So this is the point E. Okay, E is the point where it cuts BF. Okay, so here is the point E and they told this part is equal to this part. So this is the diagram given to us. Now we have to prove AF is equal to 1/3 of AC. So there is in this sum one small construction. Join, okay, join D to P. P is a point on this line. This is P. We name it P from our side. Okay, and DP should be parallel to BF. TP should be parallel to PF. That is our only concern. Okay, so at the moment we are not bothered about where P is lying. Now if we look here in the triangle ADP, isn't it? In triangle ADP, yes. So in triangle ADP, if you look in that triangle, we have AE is equal to ED and this line is going parallel to this. Okay, AE is equal to ED, EF is going parallel to DP. Yes, therefore AF is equal to FP, right? AF is equal to FP. Why is AF is equal to FP? Because by converse of midpoint theorem. By converse of midpoint theorem, we have proved these two parts are equal. Okay, once we have proved these two parts are equal, now let us come to another triangle. This time we are in triangle BFC. Okay, that is BFC. So in triangle BFC, okay, we have the line going parallel, okay, and starting from the midpoint of one side of a triangle. So we can write PD is parallel to BF, that is given, and BD is equal to DC. Therefore FP is equal to PC, right? FP is equal to PC. Why is FP is equal to PC? Because they are, because of converse of midpoint theorem, right? Converse of midpoint theorem. Line starting from the midpoint of one side of a triangle going parallel to the second side bisects the third side. So this is by CMPT. So we have got these two parts now equal. Okay, so can we now write that AF is equal to FP and FP is equal to PC, right? So we can also write it like this, that AF plus FP plus PC, AF plus FP plus PC is equal to AC. Okay, then thrice AF is equal to AC. Then we have an I over here. Okay, AF is equal to 1/3 of AC, isn't it? So we have got what we wanted to prove, hence proved. Yeah. So that is it in midpoint theorem and converse of midpoint theorem. So I have tried to pick up some of the difficult questions in this chapter, and I have tried to show you how exactly they are used to prove things in a triangle. What are the applications of midpoint theorem? Okay, so in this chapter it's very important to realize which one is where you are using converse and where you are using direct midpoint. Once you understand that, the chapter becomes a lot easier. Okay, so one thing I want to tell, before you start attempting the sums, see to it that you know the statements well. Okay, because you have to keep referring back to the words in the statement every time you try a sum. Okay, so that's it for today. We'll be coming up soon with more videos in Heron's formula, okay, and area of triangles. Okay then, so bye all of you. If you have liked the video, do not forget to like, share and subscribe. Bye then.